Okay, thank you. I'm sharing my screen. Okay, let's quickly start. Let's do a recap what we have done in last session. So in last session, we discussed about data types. We discussed about data types and we have discussed about the size of the data types. We have discussed about the size of each data type, right? Also, we have given a small introduction to the variables concept. A small introduction to the variables concept, right? In today's session, we'll discuss about the classification of variables, how many types of variables that we have, and you know, so how these variables are useful for us, right? So when it comes to the variables topic, right? When it comes to the variables, you know that variables are required for us to represent the properties of an object. Okay, to represent properties of an object. Properties of an object, right? Now, how many types these variables are, or how many types these variables are divided in Java? How many types of variables that we have in Java, right? So when you ask me, there are some classifications in the variables. There are some classifications in the variables, and there are some there are some scopes defined for the variables. There are some scopes defined for the variables. So basically, the variables are classified or divided based on data types. They are divided based on data types and based on scopes. Based on scopes. What is the scopes? We will discuss that. What is this? What is the scope? We'll discuss that. So the variables are divided based on the data types, right? So so how many data types that we have? How many data types that we have? We have eight primitive data types. We have eight primitive data types. So which means we have primitive variables. We have primitive variables. We have primitive variables. So if you use any data type, if you use any of this data type, eight primitive data types, okay, in front of any variable, that becomes the primitive variable. That becomes the primitive variables. And we have one more data type which we call user defined data type. Okay, we have user defined, or we can call them as reference. We can call them as reference data types. Reference data types. User defined, or we can call them as, or you can call them also as class type. You can call them as also, you can call them also as class type. You have user defined or reference type, reference data type. You have reference data types, right? So you have user defined variables or reference variables or class type variables. Any of that you can call. So when it comes to the data types, the variables are classified into primitive variables and user defined or reference variables. Reference variables. Okay. So if you know the examples of a primitive, anything, right? Int, age, long phone number, okay, or a double salary, roll number. When it comes to a student, it can be a college name, string name. So string name, so long roll number, something like this. So if you use any of the 8, right? So that becomes the primitive. But when you see here string is not nowhere we have found it in the primitive types. We have nowhere found it in the primitive types. So what are the 8 primitive types that we have? We have byte, short, char, int, long, float, double, and we have boolean. Only these 8. But look at string. String is nowhere available in this 8. It is not part of these 8 data types. Now what is string? String is a reference type. It's a reference type. So which means string is a class type or a user defined type. So when I'm saying string name or a string first name, string last name, it is nowhere in the 8 primitive types. So which is unknown to your compiler. This is user defined type or class type. Okay. So now if you take int, long, double, any of them, int, long, float, any of them. So they are basically primitive types, primitive variables. But when it comes to string, then this is reference type. Okay. So now, what is the syntax for defining a variable? So in Java, there is a syntax defined for defining a variable. What is this? What is that is? The syntax for defining a variable is you must have to define a data type. Then an identifier. Equal to some value, and it should end with semicolon. So the identifier is name of the variable. Okay. So data type can be a primitive data type or a user defined data type. When you ask me what is an identifier, it can be the name of the variable. Like you can take a, int a, or short b, right? Short b or long l, something like this. Okay. Now when it comes to reference type, you can say like car C, okay, pet p. So these are of class type, user defined type. Okay. House h, something like this. So here if you see, car is another object, pet is another object, house is another object, which I am representing them in the other object, So these I'll represent inside any other object. For example, if you take yourself, okay, if you have a house, then if I want to represent that house, so I have to use a variable called house. If you have a pet, then pet. Okay. So how these will be instantiated, how we can use these variables inside our program, that we'll see in the later stage. Okay. So now let us list out all the differences between the primitive variables and the reference variables. Okay. Primitive variables and reference variables. Okay. So one difference we already know. Okay. So variables are declared with declared with primitive data types. Primitive data types. Now when it comes to reference, okay, so these are declared with variables are declared with reference type. These are with reference type. Done. First we understood. Then memory allocation. Memory allocation. Memory allocation. Sorry, something happened here. Okay. Memory allocation. We'll discuss about that. Memory allocation. Memory allocation depends on the data type. It depends on the data type. Right? Memory allocation is dependent on the data type. But when it comes to reference, always, okay, your JVM allots 8 bytes. Always your JVM allots 8 bytes of memory. 8 bytes of memory fixed. You take car, pet, anything. Okay, how many reference variables that you are defining? For each reference variable, 8 bytes memory will be allocated. For example, if I am defining 3 variables, 3 reference type variables, so each variable, for each variable, 8 bytes of memory will be allocated. But if you take in case of primitive, if you are defining int, they are dynamic. If it's an int variable, int type variable, then it is 4 bytes. If you take short, it is 2 byte. If you take char, it is 2 byte. Right? Right? So memory allocation is depends on memory allocation depends on the data type. Memory allocation depends on the data type. In reference type, it is fixed. Now, one more difference. So default values. So for primitive type, default values depends on the, again, default values depends on the variables. Oh, sorry, primitive types. Depend on the primitive data types. So default values depends on the primitive data types. For example, if I'm defining a boolean variable, if I'm defining a boolean variable, the default value is false. If I'm defining a long variable, then it is 0. If I'm defining a double, then it is 0.0. But when it comes to reference, always default value will be null. Null is the default value for any reference data type. Okay. So that last and topmost primitive variables holds the values or okay, it will hold the values inside the memory okay. So basically, if any primitive variable that you take, it will store the values inside it. But when it comes to reference types, okay, when it comes to reference. Okay, so reference will store address of address of an object, address of an object. Okay, in the memory, in the memory. So basically, if you take a primitive variable, it gives you it will store the value inside it. But when it comes to the reference type, they'll store the address. So the memory location where this object is located, that information is stored inside reference variable. So what is this? What is this address? We will discuss in a short period of time. In a short period of time. So simple to say, in primitive type, the actual values will be stored. Actual values will be stored. In reference type, the address of the memory address of the object will be stored in the memory, in the allocated memory. Okay. So this is very important topic, right? So what it mean by address of an object? Address of an object. So let us do something like this. So let us take a relation. Let us take a relation. Okay. So what is the relation that I'm doing is, okay, I'm taking a car object, a car object, and I'm taking an for example Sunil, one more person called Sunil. I'm taking two different objects. Okay, one is car and another is Sunil. Simple to say, class car, class Sunil. So class has some properties. Class has some properties like name, and it has price, color, for example. It has three properties. It has three properties. So name is of string type, name is of string type, price is of double type, price is of double type. Again, color, again it is of string type. It is of string type. So now I want to represent this car object, inside inside Sunil object. Now here Sunil also will have a name. Okay, maybe his first name, his last name. Okay, now I am saying that Sunil has a car. So simple to say, car C. I am defining car object. Now first name it's of string type, so it's of group of characters. I'm using string. Last name is also a group of characters, so I'm using string. So I don't need to define for car object, because car is again one more reference type. It's of class type. I already defined a car type. Okay, car type. Okay, now one more variable I'm defining here, int age. Int age. So how your JVM will allot memory for these variables, we'll see. Okay, so now first of all, think that this is the memory, this is the memory allotted for you for your program. So your computer allotted this memory for you. Okay, think this is your memory. So first what happened? First what happened? It created it. We have to create. We have to create the car object. We have to create the car object. If I go to my, so first I have to define the car object. So inside car, I have price. I have price. First, let me identify the primitive types. I have price. Then what else I have? I have only price, which is of double type, which is of double type. And I have one more object called Sunil. I have one more object called Sunil, right? Sunil. So what is the primitive type that we have in Sunil? So we have age. We have age. So only these two we have. Only these two we have. Assume that price I'm giving it as 10K. So for example, I'm just giving 10,000 or 1 lakh. I'm giving it as 1 lakh. Age I'm giving it as 25. Age I'm giving it as 25. So now inside memory, so think that there is a classification done now. There is a classification done now. So where you have car object and you have Sunil object. And now there are two primitive types, which is price, which stores the 1 lakh value, which will store the 1 lakh value. For Sunil, it will store the age. So there is one more variable, one more memory block, which is called age, and the value is 25. The value is 25. So the primitives will directly store the values. So the primitive types are directly storing the values. Now Sunil has the car object. Sunil has the car object, right? Car C. So which means for Sunil there is a variable name called car C. There is a variable name called C, and this is of car type. Think that this whole memory block address is 11, 22, 44, okay, 55 something. I'm just giving some random number, not the exact number. So the memory address of this car object is 11, 22, 44, 55 something like this. Okay, so inside memory, inside Sunil object, we have age and we have car type called C, and this C will hold the memory address of this car object. It will not store the price value. It will not store the any other values. It will store the address. Inside the memory where car object is located. Simple to say, if you have a memory card, most of you might have used the memory card or hard disks, right? Hard disks. If you see, you create some folders. Right? Similarly, so some folders for documents, some folders for your personal things, some folders for your, you know, to some folders for your movies or songs or whatever it is, right? Similarly, inside memory also, for each object there is a separate space that is allocated. Right? So when someone asks you to copy a movie, what you do? You directly go to the movies directory and you copy it. So there is a location where you know it, in your memory, right? There is some address for it. So in C drive, or in D drive, in a folder called movies. So my personal movies or comedy movies, whatever the segregations that you do, right? Similarly, Java also does the same thing inside the memory. So what it does is it will create some space, or it allows some space when you create an object, and it will have some reference. So it can only know the numbers. Right? So one reference number it will generate, and that reference numbers will be stored inside the class type variable. So in this case for car, the memory address is 224455, right? So I'm assuming this is what the number it has given. So this will be stored inside here. So now now I am representing the car object directly inside the Sunil object. The car object inside, okay, Sunil object. So whenever I wanted to call the car, I can use this variable. So I know the memory location. When I use this variable, so your JVM knows what is the address of it. What is the address of it? From this, it can access all the variables. It can access all the data. It can access all the data. It can access all the data. I hope this is clear. So this is how it does a clarification. Any object that you create inside your memory, there is some space allotted for it. And for that space, some memory will be given. For example, 9922. Now for Sunil object also, there is some memory given. Some address will be given like 3342. Something like this. Some random number will be given. Some random number will be given. Okay. So what is stored inside this C now? What is stored inside this C now? Address of the memory location. Address of the object. Address of the object. Not the value of price. Not the value of price. Right? It will store the address of the car object. So now when I know the address of the car object, I can go and access it. I can go and access it. Okay. So any questions on this? On primitive variables or reference variables? Any questions on primitive variables or reference variables? Assuming there are no questions on this, or in case if you have any questions, please raise it now, at least over the chat, if any questions. Okay, assuming there are no questions here. So now you know that the primitives directly will store the values, but when it comes to the reference types, right? When it comes to the reference type, it will store the address of an object, which your JVM can read it and get the values from that object. Now, so you know that based on data types, variables are divided into two types, which is primitive variables and reference variables. When it comes to the scope, based on scope, okay. So based on scope, variables are again divided into three types. If you take scope into an action, variables are of three types. Okay. So there are three different scopes for a variable. So the syntax is same. Data type, identifier, and some value. You have to insert into it. Okay. Either it can be a reference type or it can be a primitive type. Okay. So based on the scope, the variables are divided into three types. There are three scopes for the variables. You can say that there are three scopes for the variables. What are those? Is instance variables, instance or object level variables. Objects are also called as instances in Java. So the object level variables. One is the first scope of a variable, that is an object level variable or instance variable. So, and the second scope of variables that we have is static variables. Okay. And third thing that we have is local variables. Now, here comes the segregation. Okay. So when it comes to object level, the name itself is saying these are dependent on object. These are dependent on object. So the variables are attached to each object. These variables are attached to each object. Okay, these variables are attached to each object. Okay, so which means object level variable changes from object to object. Object level variables changes from object to object. Okay, so what it will change? What it will change? Exactly the values. Okay, the values inside these object level variables. Okay, the values inside the object level variables will vary from object to object. Object to object. For example, if I take Anil as an object, if I take Sunil as an object, if I take pet as an object, if I take car as an object, think that everybody has a common variable called name. Everything has a common variable called name, right? So, so when I take name for Anil, the value will be something different. It is Anil. For Sunil, it is Sunil. If for pet, it can be anything. It can be something like tiger, right? The name of your pet, you can give it as tiger. Any name. For car, it can be BMW. But you look at the it's the same variable name. The variable name is same. Okay. So the value inside this variable, the value inside this variable, right, changes from object to object. Object to object. For Anil, it is something. For Sunil, it is something. You take, for example, student. You take yourself as a student, right? You take, for example, roll number for yourself, right? Roll number. It's only one variable. It is only one variable which is attached to each object. If you consider yourself as an object, roll number for you will be something. Roll number will be for others will be something. But it's the same variable, roll number, which will hold the value of different values, which will hold the values, different values, right? So name, Aadhaar number, PAN number, right? Email address, phone number, right? These are all the variables. These are all the variables. But for each object, these values will get modified. These values will get modified. So any variables where the values will change, where the values will change as per the object, as per the object. Those are called object level variables. So how do I identify an object level variables in my code, right? I hope you're clear with the statement. So which means which means any variables that you're defining, any properties that you're defining, so those properties values, if it changes from object to object to object, they are called object level or instance variables. Okay, so just keep it aside. How do we identify it? How do we identify? There is a simple technique to identify it. A simple technique. You'll understand that in when you discuss about static. When we discuss about static variables. Okay. So I hope that you understood that. Okay. The variables that you declared, the values inside the variables changes from object to object. Those are called object level variables. Object level variables. Now, what are static? What are static variables? What are static variables? So for example, when you want to define common properties for all the objects, common properties for all the objects. For example, if you take student, for a student, what is a common property for a student? College name, right? For a student, college name is common, right? Country, country will be common. Mostly country will be common, right? Right? So which are like common properties for object. So which means the values are common for all objects. All objects. The values are for all the objects are common. Okay, values are common for all the objects. Then they are defined with the keyword called static. They are defined with the keyword called static. Okay, so the common properties for every object will be represented with the help of static variables. Static variables. Okay, so how does you define a static variable? So you know how to define a variable. You have a data type and then an identifier, right? Equal to some value. So defining the value is not mandatory. Okay, if you are defining, then you have to put some value here based on the data type. Now, in front of this, if you add a static keyword, if you just add a static keyword, that becomes the common property. Now your JVM understand, okay, this is a common property for all the objects. Okay, static means it will not change. For every object, it is common. It is common. So now what is object level? If I don't define static keyword, that is object level. That is object level. As simple as it. If you define a static in front of any data type, any variable, if you define a static keyword in front of any variable, that becomes a static variable, which means it is common. There is a common value for all the objects. There is a common value for all the objects. Okay. So if you don't define the static, that becomes instance or object level. For example, now if I take Anil as an object, okay, so string country, okay, string state, okay, string country code, right, string pin code. So country can be common for everybody, max to max, okay. So I can define this as static. State, okay, if I'm defining for one state, then it's okay. Okay, this might change. State might change, right? It can be any state. It can be Andhra Pradesh, it can be Telangana, or maybe Madhya Pradesh or Chennai or anything. There are different states. So I cannot define this. I cannot define this as a static. So this becomes this becomes object level. This becomes object level. Country code. Country code will be common. So like +91 is our country code. So which is common for everybody. So this I'll define it as static. Pin code. When I take pin code might change. From object to object, it might vary. So now this is object level. This is object level variable. As simple as it. So if you define any keyword with static, that becomes static variables. They become static variable, which means they'll hold the common properties of an object, common properties or common values for all the objects. So if I take age, age will vary from object to object. So int age. So I cannot define it as a static. Age cannot be static. Phone number. Phone number varies. So long phone number. So these are instance or these are instance types. These are instance type. As simple as it. If I don't define a static keyword in front of any variable, those are linked to the object. Those are linked to the object. If I define a static keyword, they are linked to the class type. They are linked to the class. Simple to say. Okay. Instance will be linked to the object. Okay. Static will be linked to the classes. Static will be linked to the classes. Okay. Common properties are represented with the help of static. Common properties are represented with the help of static. Okay. So instance or object level variables are defined without static. Object level variables are defined without static keyword. As simple as it. Okay. Then what is local? What is local? Sometimes we need these variables to do some temporary actions. Okay. Sometimes we need these variables to do some temporary actions. So any variable that is declared, okay, any variable that is declared inside a loop, inside a loop, or as a method parameter, as a method parameter, as a method parameter, or inside a method, inside a method, or inside a block, inside a block of code. They are called local variables. They are called local variables. So the method parameters, what are method parameters? What are method parameters? So inside a method is something different. Okay, what are method parameters? So you see that we know that public's static void main we always write. Okay, what is that? You define it here, right? Whatever the definition that you give it here, whatever the definition that you give it here, they are the parameters. Parameters means some input is expected. Some input is every method will expect some input, right? Every method will expect some input, right? So that input is nothing but the parameter. That input is nothing but the parameter. Now you know that, right? So string st, right? String st. String, what is string? It's of reference type. It's of reference type. And what is st? Name of the variable. Name of the variable, which is string st. Now st is a local variable. It's a local variable for main method. Main, it's a local variable for the main method. What is this square braces? We'll discuss. What is this square braces? We'll discuss. Okay. So the scope of the variables, local variables, is very limited. Okay, any variable that is defined inside a loop or inside a method or inside a method parameter, inside a method parameter, they are called as local variables. Any variable that are defined without static keyword, any variables that are defined without static keyword, they are called instance variables or object level variables. Any variable that is defined with static keyword, they are called static variables. Static variables. Okay, any variable that is defined inside a loop or inside a method or inside a block of a code as a method parameter, as a method parameter, they are called local variables. Okay, so local variables duty is, okay, to do some temporary job. Temporary, if I want to perform some temporary actions, then we'll go for local variables. If I want to represent common properties, then go for static variables. If you want to represent, okay, object level properties, then go for instance variables. So any questions on this static, instance, local variables? Any questions? If no question, then I'll ask some question, maybe you can answer. I'm defining a class called hello. I'm defining a class called hello. And here I'm defining int A, static int B, and I'm defining a method called void show. I'm defining a method called void show, and I'm defining int C here. Int C here. So can you tell me what is this in this code? In this code, can you tell me which variable is instance variable? Which variable is instance variable? Which is static variable? Which is local variable? I have a class called hello, int A, static int B, and I have a show method. I have a show method, and I have int C inside the show method. So can you tell me what is an instance variable in this? What is the instance variable? What is the static variable? And what is the local variable? So which variable here is instance variable, which is static variable, and which is local variable? Okay. B is a static variable, C is the local variable, and A is instance. Correct. That's correct. Exactly. So here A is the instance variable, B is the static variable because I have defined the variable with static keyword. So now inside show method, the C variable is defined. So this becomes the local variable. This is local variable, and this is static, and this is instance. This is instance. So which means, which means now a value, a value will be uh, a value will change from object to object. For example, when I create hello h object, okay, so the a value for h object will be something else. Okay, hello h1, when I create a new object h1, when I create for h1 object, the a value will change. Here it can be 10, here it can be 10, and here it can be 20. And when I say hello h3, when I'm creating a new object, and here a value can be 30. So from object to object, the value will change. But when it comes to B, okay, when I say hello for h, assume that I'm defining for h, it is 30. So for h1 also it will be 30, for h3 also it will be 30, and so on. If you create hn also it will be 30. How many objects that you're creating? For every object, the value will be common for B. So when it comes to C, when it comes to, see, only it can be accessed within this method, only it can be accessed within this method, and and this object will die after this point of time, after this point of time. If show method is dead, if show method is dead, then your C variable, the memory for C variable is also released. Okay, so that's about the variables. So anything on, any questions on this? Any questions on this? Assuming there are no questions, I'm winding up the session for today. I'm winding up the session for today. If you have any questions, please note down and you will receive the notes for identifiers, data types, and variables by tomorrow. Thank you, everyone. Thank you so much.